All attendees are in listen-only mode.
Welcome, everyone. My name is Tracy Fitzpatrick, and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We're very excited to host today's webinar, Cracking Careers in Data Science. And presenting today's topic is Tarun Sukhani. Tarun is an IT executive, educator, author, international speaker, security expert, agile coach, coder, entrepreneur with over 19 years of combined professional experience, both in the U.S. and internationally. He's conducted trainings as well as facilitated training workshops in Malaysia, Singapore, and various other Asia-Pacific countries, focusing in areas of project management, consulting, leadership, management, and security teamwork, as well as other soft skills in addition to big data, data science, and machine learning. His clients have included Fortune 500 and Global 1000 companies. Now, please bear in mind that this is an overview of a very robust topic. We do offer a collection of technical and business courses that can be tailored towards your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you will get free access to the recording in the next 24 hours via email. And now I'd like to introduce Mary Feeney, Director of Corporate Learning here at Netcom Learning, to discuss some values and important items. Mary, go ahead.
Thanks, Tracy. Netcom Learning helps customers build innovative learning organization by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Data and AI practice area. Netcom Learning offers a comprehensive training portfolio for data science and big data training. Here are some of our upcoming classes on our public schedule. We have Spark version 2 for developers, which is scheduled on Feb 5. We have 20774 for performing cloud data science with Azure Machine Learning, which is scheduled on the 19th of March. We have the Machine Learning with Spark class, which is on March 5. We can also deliver these training via private training to your teams, of which the learning plan can be customized to the specific needs of that audience. These offerings can be found as well with a simple search on our website at netcomlearning.com. With this, I will turn it back to you, Tracy.
Thank you so much, Mary, for all that informative, great information. So why should you all attend today's webinar? Well, data science is a multidisciplinary field that blends scientific methods like data inference, algorithm development, and technology, processes, and systems to extract knowledge from structured and unstructured data. It helps solve analytically complex problems, and data science is a hot career option right now. You can become a data scientist with some basic and technical skills like problem-solving ability, persuasive communication, situational analysis, analytics, machine learning, statistics, and Hadoop. This webinar will walk you through the basic fundamentals of data science. It will also help you to analyze how to enhance one's self and crack careers in data science. Now I'd like to give you a quick overview of the logistics before we get started. To start with, you do have the option to adjust the Zoom window to your liking. Simply hit the escape key to find the Zoom button in the top left corner of your GoToWebinar viewer. Everyone has been muted except for our presenters. Please feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. A PDF copy of today's slides are also in the handout section of your GoToWebinar viewer. And in just a few moments, I'm going to pass this over to Tarun, who will be presenting today's topic. Okay, Tarun, you are live. Go ahead.
Okay, can everyone hear me?
Sound
I
great?
hope. Okay, great. Okay, I'll proceed. Okay, welcome everybody. So basically, I'll cover data science application opportunity. Basically, we'll talk about some of the applications of data science in business, healthcare, etc. And what is the opportunity in terms of career for those interested in pursuing data science. Okay, so one of the first questions I always get is, what's the difference between data science and big data? And I found this to be a pretty suitable definition for each of them. So data science is basically interdisciplinary field, and it combines math, statistics, computer science, and operations research. So it definitely does require that you have familiarity with several fields rather than what you may be used to in a normal job, which is just one. But of course, there are huge benefits to pursuing data science as a career, as we'll see later. It has numerous applications: fintech, genomics, social sciences, and of course the hard sciences, also known as scientific computing. Big data is basically data science applied to very large data sets. So you can basically think of big data as data science, with large volumes of data. And it has its roots, big data analytics has its roots in Web 2.0, which basically emphasized user-generated content as opposed to just content in data warehouses and databases. And we'll see later how big data, comprises four different types of data. So data science basically consists of three core components, and they are, from left to right, data architecture. And data architecture basically is infrastructure. So that's like Hadoop, Spark. It could be NiFi, Kylo, any type of data lake or whatever. So it's basically where you store your data, and that could be small data, big data, whatever. And then in the middle we have machine learning, and basically machine learning is one specific type of data analytics that focuses on uh, automatic feature extraction. And then finally on the right, we have the regular old analytics, which a lot of people are used to. This used to be called traditional research. So, when you went to pharmaceutical companies or you went to medical laboratories, they would do hypothesis testing, chi-square, p-test, and all the other stuff. And they'd be using tools like MATLAB or R or whatever have you to do statistical analysis. So if we're talking about descriptive statistics or inferential statistics, then we're basically talking about this last one on the right. And machine learning would be things like, using things like neural networks or decision trees or random forests or naive Bayesian classifiers, anything that would do kind of like automatic feature extraction. Okay, so as promised, these are the 4 V's of big data. So we have volume, velocity, variety, and veracity. Some of these should be, pretty easy to understand. They're self-evident. But let me just go through each of them, very quickly. So volume basically means how much data we have. So if we have tons of data, yeah, that would basically constitute big data. And that's probably what we would understand, in fact, as big data. But it can also be due to velocity. So maybe you don't have a lot of data right now, but the rate at which you're adding data to your database could be very high. So maybe after a year, you could have a petabyte, but maybe after a day, would be maybe a few megabytes. Variety basically means unstructured, structured, and semi-structured data. And this is where Web 2.0 comes in because, Web 2.0 introduced, of course, Facebook posts, Twitter posts, images, videos, YouTube, all that stuff. And then veracity is the source of our data. So of course, a lot of people are talking about this nowadays because of fake news, right? So, but basically they're talking about where is this data coming from, how trustworthy is the source, how authoritative is it, and so on and so forth. Okay, so obviously, we've seen a huge explosion in big data from 2009 to, and approaching 2020 now. A lot of the growth from 2015 to 2020 has been driven by IoT. And IoT is basically a way of automating data collection. So rather than humans going out and trying to gather all this data, we can have machines do it for us, and that's leading to an explosion of big data. And this is just a breakdown of data, creation by region. So you can see, of course, as you would expect, North America and Europe dominate, but hopefully the other regions and countries start to catch up. So another question that I often get asked is, what is a data scientist in terms of a very simple definition? And I found this definition by Josh Willis to be probably the best. So he tweeted this out, and basically he said that a data scientist is a person who's better at statistics than any software engineer and better at software engineering than any statistician. So basically, they're good enough. They're good enough at statistics and they're good enough at hacking to get the job done. They're by no means experts in either of those fields, but they know both of those fields. Okay, so another way of looking at it is through this Venn diagram here. So if we can imagine that you would need to have three major kind of skill sets, programming, hacking skills, math and statistics, and domain expertise, then we can consider data science to be basically the intersection of all three. And if you don't have the intersection of all three, then it's either machine learning or traditional research, or the last one, which I just have labeled danger zone here. And the reason why it's called danger zone is because if you're a programmer with domain expertise, but you don't have math and statistics knowledge, then that's not a good thing, because you could be making inferences based on data that doesn't capture all the variance. And we saw that actually in 2008 with the 2007-2008 crash, because we had all these financial experts with programming skills who basically thought that the housing market would never collapse because prices were going up for 150 years. And, we all know what happened with that. So what does a good data scientist actually look like? I think I accidentally turned on my iTunes here. So what does a good data scientist actually look like? So basically they have you can consider them six basic attributes. So one would be inquisitiveness. And this is actually probably one of the most important ones and underrated ones, because if you take a look at this particular attribute, this is probably the attribute that could have saved us from the 2007-2008 crash. And it just goes back to questioning, the data that we see. So if we see a pattern, it doesn't necessarily mean that that pattern will continue. And of course, in finance, we talk about that all the time, that past returns are not an indication of future returns, and so on and so forth. And of course, knowledgeable, background. That means, yeah, you either went to school or you took some certifications or whatever have you, but you managed to learn, machine learning, statistics, and probability, and linear algebra, and everything like that. And we'll cover the stuff that you have to know towards the end of the slides. Okay, scientific method. Basically, we create hypotheses, we test them, and update. Yeah, so everyone knows that. We do that in traditional research all the time, so everyone's quite familiar with that. Coding, yeah. Product orientation. This is another underestimated attribute of what makes a good data scientist. A lot of people think that a data scientist is, like a computer programmer or a statistician or actuary, and they don't know anything about products or product management. That couldn't be further from the truth. A very effective data scientist understands customers and they understand products. Domain knowledge, of course, that should be obvious. So if you're in finance, you understand finance. If you're in healthcare, you understand healthcare, so on and so forth. Okay, another way of looking at the same thing is basically what we want is to have a T-shaped skill set. So T-shaped means, having breadth and depth. So, height and width. So here you can see that this particular data scientist has software engineering, they have business acumen, they understand distributed computing for big data purposes, and of course, they communicate well. So they can convince people through persuasive conversation, or they can narrate or inform people, public speaking kind of thing. And also then, they obviously have the necessary deep expertise in machine learning statistics and all that stuff. Okay, these are the axes that actually govern the type of jobs or roles you can get. A lot of people think a data scientist is actually one role. That's actually not true at all. And in fact, data scientists only make up about 5% of all the different data roles out there. In fact, a data scientist is a very rarefied position, as you would expect, because it's very rare to find somebody who just knows, business, machine learning, big data, math, and all that, all the stuff listed here. So what we really find is that people specialize in a number of different areas. And I don't think I've included the data science life cycle here, but I can talk about it briefly, verbally. But basically, the idea here is that everything is broken down into 4 separate areas. So we have data collection, also known as data gathering. We have data preparation, data cleansing. We have data analytics, which is machine learning and regular old descriptive statistics and EDA. And then finally, we have data visualization, which is communicating what you found, your insight, to everybody else, the stakeholders. And so that's where we find the roles. So a data business person on the very left here, we have a data business person is basically someone who's really good at business, as you would expect. And they pretty much suck at everything else. And if you look at the very right-hand side, we kind of see the opposite, where a data researcher kind of sucks at business, but they're really good at statistics. And then we have everybody in between, right? So we can have data creatives, and these people are basically really good at programming and machine learning and big data, and and data developers who also basically are good at machine learning, big data, and programming. However, they're not as good at statistics as, let's say, a data creative. Okay, another way to crack data science is basically just to brute force it. So you could actually just learn all these 10 things and kind of brute force your way through data science. And of course, you could take courses online, or you could take courses blended or face-to-face, it doesn't matter. But you would have to cover probably all these topics if you wanted to be that 5% of the rarefied individuals who become data scientists. But of course, you don't have to do that. You can just choose one of those roles, as I mentioned. I'm not going to go through all 10 of these in detail, obviously. We don't have kind of time for that. But let me just summarize by saying, yeah, you've got to go through the fundamentals, which is basically math. And math is like linear algebra and statistics, all that stuff. Then you've got to go through programming and machine learning. You do have to cover text mining, natural language processing, but that's only if you're actually focusing on that area. And of course, text mining NLP is part of machine learning. So if you have nothing to do with machine learning and you're just focusing on analytics with descriptive statistics and inferential stuff, yeah, I mean, you don't have to learn that. And then the rest of it is big data and visualization and data ingestion, and which is basically data preparation and cleansing and collection, all that stuff. So there are people who are just doing data collection, data gathering, and then there are just people who just do data preparation and cleansing. They don't do anything else. So sometimes data analysts do those first two things, and they just, they don't do anything else. Okay, so I think we've pretty much kind of covered, like what you need to know to be a data scientist, at least from a broad overview. So let's talk about job opportunities. So basically, data science has been dubbed by the Harvard Business Review in 2012 as the sexiest job of the 21st century. Even the New York Times commented on it and said it's going to transform, blah, 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 everything. But, data science is not anything new. When I was in school, very, very long time ago, we called it business intelligence, data mining, and data warehousing. And in fact, that's what I got, my MS in. So, because back in those days, we didn't have Web 2.0 and things like that. And that's what it was called. And basically, it's just a rebranding, I guess you can think of it, of data mining, because we use a lot of the same algorithms and everything. The only difference is that data science now has become more holistic, and it's combined in many ways some of the things that we've seen from big data. Okay, so Glassdoor did a survey on these kind of data scientists, and they found, surprise, surprise, that they're very highly paid, they have great work-life balance, and there's tons of job openings. So yeah, I mean, this is a hot field. And in fact, by this year, 2018, there's expected to be a huge shortage of data scientists. And as I mentioned earlier, you don't have to be that 5%, you can be the 95%. And there's like 1.5 million positions for that 95%. So yeah, I mean, the demand is there. Okay, so why is data science in such high demand? And the reason is because this particular role combines a host of disciplines that are necessary in a company to do business process automation and prediction. So every company, small, medium, and large, needs to do two things effectively. One is automation. They've got to improve their business processes, to reduce, of course, time to market and all that stuff. But at the same time, they want to make predictions about, whether it's a supply chain thing or make predictions about, churn rates for their customers, and so on and so forth. So they've got to get better at ROI, right? So this type of position allows companies to really strategically improve themselves. And so that's a very, unique position to be able to affect the entire, strategic outlook of a company. And so that's the first principle, which is socio-technical systems are complex, right? So data science is a combination of a social, kind of position where you're dealing with people a lot, and technical, where you're dealing with code a lot. So that's why it pays a lot more. The other thing is data is never at rest. I think we saw that, with all the hacks that are happening and everything like that, you can't just expect your data to stay in one place in a database like it was 20, 30 years ago. Nowadays, that data is being shared everywhere, usually through APIs, right? So we know that already because of Facebook and everything. Data is dirty, deal with it. Yeah, I mean, when you get a data set, it's very rare that there are no typos, there's no missing data, there's no transformation required. I mean, that's not going to happen. I mean, chances are you're going to have to go through and make changes. There's no single version of truth, right? If you go to the operations department or you go to finance or accounting, they're going to give you a different story about what's happening in the company. And it's usually the confluence of all of this that is usually some, version of the truth. Data munging or wrangling or wrestling or whatever adjective you want to use to describe it. This is the data preparation cleansing side of what I mentioned earlier, which is the second part of the life cycle. Well, the problem is that data gathering, collection, data preparation, and cleansing make up about 70% of the time that a data scientist spends in the full life cycle. So that kind of sucks. And that's the main reason why so much emphasis is being placed on data collection and data preparation cleansing. So on the data gathering side, data collection side, we focus on IoT, and that definitely gets us tons of data in a very short period of time in the right format. And data preparation cleansing, we have tools, commercial tools like Informatica, which is like from my day, long time ago, but it's still being used, of course. But it's really expensive. But we have open source tools too, like Python and R, and those are kind of like vendor agnostic. So you can do the cleansing that way. And then we want to do simplification, reduction, distillation. That's the job of a data scientist, is take tons of data with potentially hundreds of features, i.e. hundreds of columns, and distill it maybe into a few insights. There could be hundreds of insights, but maybe only a few of them result in major ROI for that company, and that's what you want to relate. And anyway, as we all know, board members don't have time to absorb 100 different insights. Usually 3 or 4 is more than enough. And then curiosity and all that stuff, which we've talked about. Okay, so I'm sure a lot of you guys are familiar with Donald Rumsfeld, from the Gulf War, Persian Gulf War fame, of Persian Gulf War fame. And so he served actually under both the Bushes. But anyway, during the Gulf War, he was talking about to a journalist. There was a press conference, and then he was talking about this idea of known knowns, known unknowns, and unknown unknowns. Basically, he was talking about the fog of war. So, for example, there are things that we know. Like, for example, we could know our enemy's troop levels, right? And then there are known unknowns. So we may know that the tanks are hiding out somewhere, but we may not know exactly where, right? But we know that they're there somewhere. And then finally, there are unknown unknowns, right? Things that we don't know that we don't know. And that's what happens in war, right? I mean, bad things happen. So, and the same thing happens in data science, right? 2007, 2008, and things like that. Those are, kind of cited as unknown unknowns. So how does this fit within our framework? Well, basically, the goal of data science is to reach wisdom, and wisdom allows us to predict unknown unknowns. We saw this really clearly with AlphaGo. AlphaGo was the program that was created by DeepMind, this very advanced deep reinforcement learning algorithm, and it beat the world champion, both in South Korea, Lee Sedol, and in China as well. And basically, it slaughtered them. And how did it do that? And the reason why is because it was able to pick up on a new ways of playing the game of Go that human beings never even thought of. So that's really an unknown unknown. And so that's, wisdom right there, right? But basically, we're trying to go from left to right. So we take raw data and we work our way all the way to wisdom. And along the way, we have the different roles, and they're doing their thing. As we mentioned, there's many different roles. But the data scientist, of course, is that rarefied 5% that can get us to wisdom. Excuse me. So here are some of the statistics regarding return on investment for companies that do choose to adopt data science within their operations. And of course, the short story is, yeah, they do better than other companies. Okay, so what do companies actually want to do? So companies want to create data products. And how do they do this? They do it through data-driven decision making. What that means is that rather than using intuition and things like that, your gut, all the major decisions are driven through collected data. Okay, so I'm going to kind of quickly go through some examples of data science, some applications across different businesses. So let's pretend you're a media company and you've got a bunch of articles over decades, right? And no one labeled these articles as to what kind of categories they belong to, but you want to try to group them as much as you can. So this is an example of unsupervised learning, and that means because we didn't have any labels, we didn't label these articles as to what category they belong to. So there's many different types of algorithms you can use. When you do unsupervised learning and you want to group things together, that's called clustering. And so we could use an algorithm like k-means clustering or hierarchical clustering to do that. And there you go. What about if you have something like this? You're in a retail e-commerce environment, and you want to know, like, hey, if some guy bought this, is it likely that they'll buy something else? Hey, maybe I should show them a voucher, so that they'll definitely buy it. So that's called market basket analysis. And there's an algorithm for that. So the algorithm is association rule mining, for example, and we could use that, and that's a machine learning algorithm. Okay, what about another example? Well, one interesting thing about algorithms is that they can apply across different industries. So it's not like, for example, market basket analysis only applies to retail or e-commerce. We can use the same exact algorithm in healthcare to predict diabetes, for example. And how would that work? It's very simple. Association rule mining basically says that if one or more of these rules are associated with each other, it's likely that something is true, right? So if we have, let's say, one of these things is true, let's say you have high glucose, okay, well, maybe you have a chance of having diabetes. Well, what about if 2 or 3 of those things are true? Well, then the chances are much higher that you have type 2 diabetes. And again, we use the same algorithm for that. Okay, what about if you do have labeled data? So let's say you've labeled some tweets and now you've got some new tweets and you want to label those. Well, that's supervised learning. When you have supervised grouping, that's called classification. And there are plenty of algorithms you can use to do classification. You could use a decision tree, a random forest. You could do naive Bayesian inference, a classifier that way. You could use a neural network and so on and so forth. But let's say, in this particular case, we use a naive Bayesian classifier. And, the applications go on and on. I'm not going to go through all this stuff. Recommendation engines are a great example of, machine learning in action, using to make a prediction. And again, that could be a combination of market basket analysis, pattern recognition through neural networks, and so on and so forth. One thing that I wanted to make clear is that a data scientist doesn't just use one algorithm. Usually they'll use 3 or 4 algorithms and then compare them. And sometimes they'll just combine them also, and that's called an ensemble. So it's not like you go study one thing for one domain and you just use one algorithm. It doesn't work that way. As we've seen, algorithms can go across different domains. Okay, so a company wants to design data products using this idea of data-driven decision making. And so how do we do that? So basically, we've got to get that data into a particular format. It's got to be curated properly, right? We've got to make sure that that data is correct. We've got to do some EDA on it. We've got to analyze some of that data, univariate, bivariate analysis and stuff like that. The stuff that we learned in statistics class. And then we've got to identify what type of predictions we want to make. What is the independent variable and that we're trying to predict and stuff like that. Okay, so this is what we've got to work with. We've got objectives that we set up in the beginning. What are we trying to achieve? Are we trying to automate this process? Are we trying to increase our ROI? Blah, blah, blah. What are we trying to do as a business? Now we have to figure out, well, what can we control? Well, obviously we can't control our competition. We can only control, what we can do operationally. So we focus on what we can do operationally. Then we collect the data from the operations, and we build a model around that. And that's the model that we use to make predictions. So you've got the world, and the world has a bunch of data. We want to ingest that raw data. We want to munch that data, prepare it, cleanse it, get into that right curated format, and then we pump that data set into our EDA analysis, and finally into basically a program, right? An application, a platform, a system. Somebody's got to code it. And so once it's coded, then it can be used to make predictions. And now those predictions, can either be assisted decisions or they can be completely autonomous. So if you look at like self-driving cars, that is prescriptive analytics, meaning that the system is making decisions on its own without any human input. And of course, you can also visualize that insight as well. So that's it. We want to do, getting that data in, modeling it. We can simulate some, fake data and see if we get the right quote unquote right result or expected result. And then we optimize. Okay, so I'm going to end with like what you need to do to if you wanted to do data science as a career. Again, as I mentioned before, only 5% of people ever reach this intersection. Most people are doing either of these other things. And as I said earlier, this is the danger zone. This is like the Dunning-Kruger effect in action here, right? Because you don't want people who don't understand math and statistics and then go out into the world and tell the business completely wrong things. Okay, who are some examples, of data scientists? That I'm sure you want to model yourself after somebody, right? Well, if you do, you've got a couple of choices. So DJ Patel was the chief data scientist under Obama, and he's actually the one responsible for the LinkedIn People You May Know feature. So he's basically a data scientist. Now, if you look at Doug Cutting is a data engineer. And so he's basically focusing on the infrastructure part of things, which we saw in the very, beginning slides. It was the thing on the left, right? The infrastructure thing. Okay, so this is what you got to know. You got to know a high-level language. You got to know a low-level language. Just pick one. Some people may learn more, but that's probably overkill. Then mathematics. So you got to learn linear algebra, calculus, graph theory. Graph theory means you've got like the social graph from Facebook. Then probabilities and statistics, and combinatorics is just the different permutations of things and what's an optimal permutation or combination. And then statistical analysis, all the statistics stuff. Then machine learning, software engineering. But you don't need a PhD. You can just take a bunch of courses and get up to speed and do data science on the side. Join Kaggle, sign up for all the blogs and stuff, like KD Nuggets and our bloggers and stuff like that. Just get familiar. Read a couple of research papers, maybe on deep learning. Just get up to speed on the subject itself. So you don't need a PhD at all. But a lot of people get into data science, of course, as you would expect from software engineering or from regular old analysis and econometrics. But believe it or not, there are some unexpected people that get into data science, especially gamblers, right? Because they love to make predictions. And I'm going to do a quick demo if we have time. I hope we have a few minutes.
Yes, you do. So go for it.
Okay, great. So I'm just going to do a quick demo of a decision tree. And this is our data. So what we're trying to do is we're trying to predict whether or not someone gets hired based on these features, right? So whatever I'm highlighting is called X, right? So these variables influence Y, and this is Y, right? So I've already labeled it, right? So what kind of learning is this? This is supervised learning, right? So what algorithm can I use? Well, I could use, maybe a neural network, or I could use a naive Bayesian, thing. But hey, I've decided to use a decision tree, right? And each of them have their pros and cons. So what I'm trying to do is I'm going to feed this data into my decision tree, and I'm going to give it new data points, and I'm going to see whether it says that person should be hired or not. So I'm going to do this in Jupyter. So if we take a look at Jupyter Notebook, this is my decision tree, right? So this is Python. And those of you who are familiar with Python and Jupyter Notebook may recognize this right away. I'm not going to go through like what libraries I'm using, but just follow along. So I'm using this data, the past hires, which you just saw, and I'm going to import the data. So I've imported the data, and you can see part of the data here. And now I'm going to convert the data to numerical, okay? So whenever you use any of these algorithms, machine learning algorithms, you got to convert all the yes, no's, and all the categories into numbers. So that's what I'm doing here. So as you can see now, everything is a bunch of numbers. And now I can input those numbers finally into my algorithm. So what I want to do is I want to say what's X and what's Y. So X, of course, are my, my first 6 columns. And so I'm gonna, take those out, and that's my X, right? And my Y is the last column. So you see that here. And now I'm gonna create my decision tree classifier, and I'm gonna fit X and Y. And what happens after I do that is that it figures out automatically what my decision tree will look like. And I'm gonna draw my decision tree, and here you go. This is our decision tree. So what this basically says is, if you're employed or not, which direction you should go, right? So employed less than 0.5. So if employed is 0, what does that mean? It means you're not employed, right? So if you are employed, you go to the right. So it's kind of like counterintuitive, but you've got to pay attention to the sign here. So if you are employed, we're going to hire you. So this 0.5 means 0 means we're not going to hire, and 5 means we're going to hire. So we're going to hire those 5 people. So it looks like, based on our data, the most important thing is whether you're currently employed or not. Now, if you're not currently employed, we're going to take a look at whether or not you had an internship. If you haven't had an internship, we're not going to hire you. If you did have an internship, we're going to take a look at your education. If your education sucks, in other words, if it's less than 1, right, we're going to hire you, believe it or not. And if you're too smart, we're not going to hire you. So if you're like a PhD, for example, we don't want to hire you. And of course, this is kind of made up data, but you may recognize this as being pretty accurate. And again, there are flaws in this, as we'll see. So now I'm going to use this to actually make a prediction. So let's say I have 5 years of experience, I'm currently employed, and so on and so forth, right? Or if I have 10 years of experience, I'm not currently employed. I can run this and see what it says. Well, the prediction is, for the first one, I'll be employed, and the second one, I won't be employed. And it looks like, this definitely has an influence. If I said, let's say you weren't employed, right, then it becomes 0, right? So it definitely seems to care a lot about whether you're currently employed or not. And that's why it was the first thing in the tree. So we call this the first split. I'm not going to go through like the rest of it. And so I'll end it there. And I hope that it was helpful. And that's it for me.
Okay, great. Thank you so much, Tarun. That was most informative. And we do want to remind all our attendees, let's see, that we do have, Netcom Learning does offer a comprehensive portfolio for data science and big data courses, which you can see up there on your screen. There we go. And you can enroll in any of the recommended courses that you do see. So to definitely take advantage of that. Team training can also be customized and accelerate to meet your organization's specific needs. You can contact us today to be connected to one of our learning consultants who can help and advise you on your specific needs, or you can email us at webinar@netcomlearning.com. And also you can search our catalog at www.netcomlearning.com to learn more. Technical skills are necessary to empower your career, but do you need to improve or upgrade your leadership skills as well in order to accelerate your career? Along with your technical abilities, you can develop the skills you need to manage yourself, others, and business better. Welcome to Starter Learning, a collaborative knowledge platform bringing the world's best business and leadership insights from Fortune 1000 leaders, best-selling authors, and Ivy League professors. Further, if you are interested in learning from the top American leaders, please log on to the e-learning platform at starterlearning.com and you can avail the special promotion meant for first-time users. You can use your coupon code STARTER10 and begin your leadership journey right now. And now we are going to launch a quick poll to find out how many people might be interested in taking some additional training. So please take the time to fill that out before you all log off from today's webinar. In addition, we do have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register. And don't forget to follow and like our social media pages to get the latest technology updates. You can refer to the GoToWebinar chat window to catch our links. And Toron, before we end today's session, do you have any other final thoughts you'd like to share with our attendees?
Well, nothing, I guess, specifically, but just in general, if, there are any questions about data science as a career path, I'm willing to take a question or two.
Well, great. Thank you so much. And thank you all of you who attended today's webinar. And if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.